Hello, everyone. Today I'm here with Aaron Drake. Aaron has a long history in tech, working in the Bay Area with various e-commerce companies such as Google, Shutterfly, RockYou, which I believe is a gaming company, Augur, which does blockchain, and recently he has transitioned to Stanford University, where I believe you're a software engineer.
Right.
So welcome to the show, Aaron.
Thanks, John. Good to be with you.
Thanks. So tell us a little bit more about your history with these companies. Google, I think most people know what they do, but tell us about what you did there and then at Shutterfly, RockYou, and Augur, if you don't mind.
Okay. So when I was at Google, I was on the Google Analytics team, and a lot of what I did there was working with some of the customers who use Google Analytics, and a lot of it was actually troubleshooting the issues that they had with their sites. So they would basically put JavaScript code on their site, and then it would provide various tracking stats about their users. And a lot of times their customers would encounter problems, and I would help them fix that. And if we encountered bugs, those would get reported and so forth. So I was there for about a year, and then
So they're like
after that,
a
I
support kind of, basically, it sounds like.
sort of, yeah. And it was actually a temp to hire position. So
Okay.
it was basically um, a lot of their employees kind of start out that way, and then
Hmm.
um, assuming that they have good performance, then they eventually become full-time employees. But
Right.
what happened when I started was they ended up having a hiring freeze due to the financial crisis.
Hmm.
So unfortunately, they weren't doing um, the full-time conversions to or the temp to full-time conversions. So it was kind of disappointing for me because it was pretty early in my career, and I had moved across the country
Hmm.
to take that job. And so, anyway, basically at that point, I kind of decided that I wanted to stay in the Bay Area and continue working at startups. So then I went to a startup called Wikia, which was started by the Wikipedia co-founder Jimmy Wales,
Hmm.
and they basically run a lot of smaller wikis that are kind of similar to Wikipedia, but they're focused on specific topics. So they have communities that are very, like it's kind of like a more detailed version of Wikipedia. So you can go there and find, for example, there's some of their more popular wikis are gaming related. So they have a lot of wikis devoted to particular video games, and you can see walkthroughs and all kinds of things. So I was a software engineer there for a little while. Then I went to another company called RockYou, which was, as you mentioned, that's another kind of gaming company. They create Facebook apps, and that was kind of when the social media app craze was going on.
Right.
It's not as big now, obviously, but then I went to Shutterfly, which is pretty well known. They allow users to create, kind of custom photo cards and photo GIFs, and was a web developer there. And then worked at Augur, which is a blockchain startup. Um, their project is essentially allowing users to create their own prediction markets. So prediction markets are, if you've ever used the site Predicted, there's different markets there that people can bet on for things like a lot of them tend to be politics related. So you can bet on the outcome of elections and that sort of thing.
Gotcha.
And this tool allows people to create their own prediction markets that people can bet on. And then most recently, as you mentioned, I'm at Stanford University in their IT infrastructure department, and I work there as a software engineer.
Cool. All right. So let's backtrack and look at some of these because you've done a lot of really interesting things. Kind of jealous, to be honest. Uh, let's talk a little bit about blockchain. Now, I'm basically familiar with the concepts. I just finished a couple LinkedIn learning tutorials on blockchain, but a lot of the audience here of this um, uh, podcast probably doesn't really know what a blockchain is. So could you give a really brief overview of blockchain technology?
Yeah, it's one of these words that's kind of difficult to define succinctly, but essentially it's kind of like a decentralized database or ledger that contains, in the case of Bitcoin, for example, it's sort of like a ledger of all of the transactions that occur between all of the various Bitcoin addresses that users have. So Bitcoin addresses are sort of like email addresses in a sense. Each person can have their own address. They don't really get to customize them like an email address, but essentially it's a unique address specific to them that they can control. And from that address, they can either send Bitcoin or receive Bitcoin. So the blockchain is just a very long history of all of the transactions that have occurred.
Yeah, and I've heard that decentralized database or distributed database is a similar term. So, and if my understanding is right, and you're the expert here, so please correct me if I'm wrong. That's basically like every time you said, I think every time there's a transaction or every time something changes on one of this distributed databases, it has to appear on all the databases, and because it's kind of like almost like peer-to-peer database structure, but
It is, yeah.
also some sort of authentication built into that as well. So they're all identical.
Yeah, basically the way that it works is there are a bunch of different Bitcoin nodes that all run across the internet on different computers, and they all have to reach a consensus essentially as far as which transactions have occurred. And so this goes back to kind of a problem in computer science called the Byzantine generals problem, which is it's basically the problem of, suppose you have two generals that are part of the same army, and they want to send messages back and forth about coordinating an attack against the enemy, but those messages have to go through a series of kind of relayer people who send the message to someone else. And so the problem there is that any of those relayers could potentially be an enemy. And so you have to figure out a way to, establish a connection between these two people that can be trusted.
Gotcha.
And so Bitcoin kind of attempts to do that by having all these different nodes that run separately, and then they have to form a consensus about what transactions have occurred. And as long as a majority of them agree on that, then that transaction gets added to the blockchain.
Okay. And so Augur is attempting to apply this to betting. Is that correct? This blockchain
Right.
concept. Now, are they? What platform are they building that on? Is that Ethereum or?
That's built on Ethereum, yeah.
Okay.
So Ethereum's its own separate blockchain. And the difference, one of the key differences between Ethereum and Bitcoin is that Ethereum allows for the creation of smart contracts, which are they're sort of like little programs that can run on the blockchain, and when certain conditions are met, they can automatically perform transactions between different accounts.
Okay.
So what they're trying to do is it's similar to Predicted, but the problem with Predicted is it has a number of limitations. For example, there's limits on the amount that you can bet on certain markets, and with Augur, there's no actual limit on that. So this is something that traders have a big demand for. And the other thing is it allows people to basically create a prediction market on any topic that they choose. And so, of course, this gets into potential legal complications because it's sort of a legal gray area. But essentially, all of the data is not hosted by Augur. It's all on the blockchain. And it's also hosted locally. In version 2, it's going to be locally within the browser. So the user, essentially, the way version 2 is going to work is the user will start using Augur, and it will sync with the blockchain and essentially cache all of that Augur-related data locally in the browser. And this is kind of a weird architecture. Normally you don't do this for a lot of websites, but if Augur were to host the data themselves, they would be considered a market operator. And so that would be subject to a lot of regulations by the SEC. So by having the user host all of this, it's sort of a workaround for that.
Okay, okay. Now you mentioned the smart contract idea. Is Augur using smart contracts in there? Um,
They are, yeah. It's actually one of the biggest apps as far as the sheer amount of smart contract code that Augur has. It's actually quite complex, and there's a lot of different smart contracts that they deploy for their entire app. So it's definitely one of the more ambitious apps out there.
Cool. Yeah, I'm curious to see where it goes over the next few years, and it was because that was one of the companies mentioned when I was listening to this LinkedIn learning tutorial on blockchain. They mentioned Augur as one of the companies that's developing new apps on the Ethereum platform. So it was very, very, very interesting.
Yeah, and it's interesting when you get into prediction markets, you start to realize some of the not so obvious applications that this could have. So it's not, betting kind of has this very negative connotation in a lot of people's minds. But if you think about insurance, it's actually a form of betting.
Yeah.
And if you create a prediction market on, like, say you want to create a prediction market for whether a particular flight will take off on time, and then you bet money that it won't, that essentially is like buying flight insurance. And so by creating prediction markets that are highly customizable, you can greatly reduce the cost of insurance in that sense. So you can, it's not quite like insurance in the sense that you kind of have to figure out the odds for yourself, I guess. It's,
Sure.
I don't know, there's different risks involved, but it's potentially a way that insurance could be done that's a lot cheaper and has lower overhead because the smart contracts automate a lot of the transactions there.
Do you think there's a potential in the future, and maybe not with Augur, but with a similar platform that could disrupt the insurance marketplace?
I think eventually that's going to come. Whether Augur is ultimately successful remains to be seen, but I think eventually somebody's going to crack that and figure out a way. And I think that's going to be pretty, yeah, as you say, disruptive and pretty revolutionary in terms of the insurance market.
Yeah, yeah. Well, I mean, they already got enough issues to deal with autonomous cars coming down the road and
right. Yeah, that's true.
Okay, so and then at RockYou, you said you developed gaming apps. Were you part of? Give me some of the apps that you were involved with at that company.
So one of the biggest ones for them was called Zoo World, and it was sort of similar to Farmville, but you run your own zoo and you can buy a wide range of animals and all kinds of items for your zoo. And that was, the front end of it was built in Flash, and then the back end of it, if I recall, I think it was MySQL. But yeah, it's very similar to Farmville.
Okay, cool. And then you mentioned, I guess Shutterfly, and right? Or wait, did you? I thought there was another one in there somewhere, like Tiny Prints. Is that what
well, so Tiny Prints was, yeah, I initially started at Tiny Prints, which was a startup that later got acquired by Shutterfly.
Okay.
But they did something similar where they allowed people to create photo cards and photo GIFs on their site. They were kind of more of a premium brand, though.
Got it. Okay. So now you're at Stanford University. What type of projects are you working on there?
Well, currently we're in the process of starting to utilize MuleSoft's Anypoint platform and Anypoint Studio. I'm not sure if you're familiar with those, but MuleSoft is a company that got acquired by Salesforce a few years ago. And their software allows you to very quickly and easily create APIs. And you can specify very fairly complex flows for your API and what it should be doing using simply XML, and it'll take those, and you can connect to other APIs, get data back, transform that data, connect to databases, and kind of it's a way to combine all these different pieces that you would normally use for creating an API very quickly and easily. And then it has a language called DataWeave that allows you to transform that, and then you can output that as your API response.
So is that kind of like a middleware that sits between APIs, or how or am I misunderstanding?
Well, they have their own cloud cloud platform where you can take the code that you've written and deploy it. And there's two different platforms. One's called Cloud Hub, and the other is called Runtime Platform. We're using Runtime Platform, and so it takes this XML, creates a Java jar file, and then you upload that to their cloud platform, and then that creates an endpoint that your users can connect to the API, and then it connects to databases or other APIs, takes all that data, processes it, transforms it, and then sends it back to the user.
Okay. Trying to think if there's a good analogy that I could use, but I don't know. That's getting pretty complex even for and like, so a lot of my students probably, like, they don't even know what an API is.
Okay.
So that's good. I mean, at least within the information MIS field. Now, maybe computer science students might have a little more familiarity with it.
Okay. Yeah, I wasn't sure, what your students and listeners, or what their familiarity with APIs and programming are.
So, but it sounds like you are trying to make it easier for people to access applications in the back end through.
Right. Exactly.
If I wanted to.
Yeah, it's essentially creating a URL that the user can call that returns data in a particular format.
Got it. Okay. Whew, all right. So you're doing that at Stanford, and is that to help connect some of the Stanford internal applications?
Yeah, so, well, I work in their voice communications department, which is, it sort of functions like Stanford's own telco. So they handle a lot of the voice communications that go through Stanford, both in and out, and they maintain the call record information, a lot of metadata about those calls.
Mm-hmm.
So things like what number called another number, how long the duration of the call was, whether it went to voicemail, all these different things. And then they also more recently have been working with Zoom because, of course, with COVID-19, a lot of their employees have been working remotely. Right. So the amount of Zoom API work has also shot up quite a bit.
I would imagine, yeah. How easy is it to work with Zoom and their API?
I actually haven't done too much with Zoom yet. They have some APIs that you can utilize for a lot of the functionality in Zoom, but I've been more focused on the telephone APIs.
Yeah, and what I find it just fascinating is how much even telco now. I mean, you were talking about having to have access to this URL, so it's even the voice communication is all. And I don't necessarily if your system is all IP based, but even if it's not, it sounds like your ability to control that system is all web based, and that's not just internet based, but web based access to these files, which is I find fascinating.
Yeah, there's the regular old fashioned telephone, and then there's of course VoIP and Zoom and a lot of different forms of communication that all that information needs to be accessible through the internet.
And so you mentioned you're doing writing XML and was it JavaScript something or another Java?
Oh well, the app that gets generated by Anypoint Studio is a jar file. Yeah, so
a jar file. That's it. Okay.
Yeah, so it's the platform itself. The platform itself is, or Anypoint Studio is built on Java.
Okay.
and then your app is it ends up being a large part of it is XML files, but then there's also a fair amount of data weave code, which is like, I don't know, it's pretty much only specific to Anypoint Studio and Anypoint platform. I don't think data weave as a language is used within too many other applications.
I've never heard of it. Yeah. So XML, and so you, I guess they prefer that over JSON as far as your.
Well, our APIs actually do output JSON.
Oh, do they? Okay.
It's just the flow, how you define your flow for your API and what it should be doing, and the various connections it should be making. That's done within XML.
Okay. Okay. Nice. Wow. Yeah. This is getting deep, man. I like it.
It's quite a change from Augur, where pretty much everything we did was in JavaScript. We used Node.js and then JavaScript on the front end, and it was.
So Node.js is a library, a JavaScript library, correct?
Well, yeah, it's a way to run JavaScript on servers.
Okay.
So you can run it on the back end.
Okay.
As well as traditionally it's been used to just run within the browser. But there's a fair number of companies now that use JavaScript both on the front end and back end.
Yeah, I've heard about that. It's growing in popularity on the back end as well. Do you know why they decided to go with Node.js on the back end?
Well, so initially, there were two versions of Augur. The first version was quite a bit different, and it was actually an app that ran locally on the user's computer.
Okay.
And that eventually they wanted to get away from that because just having an in-browser experience is a much better user experience.
Okay.
They also wanted to come up with like a better way to quickly sync with the blockchain. And the version 1 was very slow. And they came up with a more efficient way of doing it within the browser. But since they wanted to have everything in the browser, JavaScript's kind of one of the only options there.
Right.
WebAssembly is eventually kind of potentially going to be an option, but just having everything in JavaScript was kind of the best way if you just wanted to run everything in browser.
Got it. Okay. Interesting. All right. All right. So I want to get you a little bit harder question here, in case it hasn't been hard enough. So try to think of a situation or a hard problem you've had to deal with on the job. And so I'm kind of hoping you can kind of talk through what that situation was, what was your thought process in the midst of that dilemma, and what its outcome may have been. Can you think of anything like that?
Yeah, when I was working at Augur, one of the things that we encountered. So I was working on some of the APIs for Augur. These again are like endpoints that are used to fetch data from a database. And I had written the code for this API, and most of the data related to Augur we had already been storing in the database. And for some of these API functions, I was attempting to retrieve that data from the blockchain directly, and that turns out to be significantly more expensive in terms of performance. And this was something that, I don't know, in hindsight, I really should have realized it sooner, and should have realized, oh, we actually need to be putting this database in the data, or this database, we need to put this data in the database as well. And I guess I was just thinking, okay, I think we've got all the components we're going to need in the database. And so this was being fetched within a loop. And so it was, of course, performance-wise, adding up, the more Augur data that was being created, the longer this was taking. So essentially, like, we didn't catch it early on because when we were first testing, we didn't have a lot of prediction market data. And so we didn't really get that it was going to be this much of a performance hit. And so, and I also had some unit tests for this that were not generating tons of data, so it wasn't catching it there either. But as we were doing more thorough testing and building up more markets and placing more trades, we started to realize that this was pretty slow. And so eventually I realized, oh, this is actually, we need to be putting this data in the database. And so, yeah, it was just kind of one of these things where, in hindsight, it was a dumb mistake, and it ended up that we had to rewrite some of this code and change some of the database schema so that we were keeping this data within the database. So yeah, I guess that would be the one that sticks out the most, just because it was it took us a little while to track down why this was being so slow, and if I had caught it sooner, it would have saved us more time, because we wouldn't have had to rewrite some of the code and so forth.
Yeah, that sounds, yeah, I've, from my few years doing programming, those were always the most difficult situations. There was a time when we were doing some consulting at Anheuser-Busch, and our application, we went in, we had our own application we installed on their servers and connected to their database, and yet the system was running extremely slow, and we had to try to track down why in their environment it was going so slow. And it ended up being a completely different problem. It was actually the connection between the web server and the database server. Something was going on there that was preventing the data to flow. But trying to track down those types of problems, whenever you have performance issues like that, that's
Yeah, we also had an interesting issue when I was working at Stanford recently, where we had a nightly script that was running every day at about 2:30 a.m. And one day it just started hanging, and it wasn't importing all of the database, or it wasn't importing all of the call data records into the database. And it took a while to realize what was happening was, unbeknownst to anybody, there for a long time, there was another script that was dumping very small call records into this one directory. And over time, it just got to be millions and millions of these log files. And we were archiving them into larger files so that we just had a few files each day. But these were like, a lot of these logs just had 1 or 2 calls in them per file. And so you just got millions and millions over several years. And eventually it was trying to walk the directory structure and find all of the files. And it was just kind of getting stuck on all of these, trying to list all the files in this one directory. So we ended up copying just the directories that had the archived files that we needed out of there, and then deleting that single directory. But initially I tried just deleting those specific files from the directory, and it was just hanging because there were so many. So the only way we could do it was just to move the good stuff out of that directory and then delete that entire top level directory.
Wow. Yeah. All right. Well, let's talk a little bit more about your career here. So you've had quite an interesting career, a number of really interesting technologies you've been working with. What have been some of your hardest career choices that you've made?
For me, I would say a lot of those have been the ones that kind of intersect with my personal life. So, for example, moving from St. Louis to the Bay Area was quite a big, change for me, and there were a lot of risks involved because I'd never really even been to the Bay Area, knew practically no one out here. It was, and it also meant that, of course, I wouldn't be able to see my family and friends as often, and so it was a risky move because I was working at Google, which was a company that it was one of the few companies that I would have moved halfway across the country for. and so I decided, well, I'll give it a try, see how it goes, and if I like it, I'll stay, and if not, then I'll move back. But I guess another one that comes to mind is, after that temp to hire position at Google didn't turn out for me, I kind of had a choice where it was like, well, do I want to stay out here and try to
Mm.
stick with working at startups and that sort of thing? Because that always had interested me, and I felt like that was where a lot of the innovation was happening in Silicon Valley. So I did end up staying out here and sticking it out, and overall, I'm glad I did. I mean, it was definitely a good career choice, and I've learned a lot. Um, and then the other thing that comes to mind is recently taking this job at Stanford. I decided to do that because working at Augur, working at that was definitely the startup that had required the most work hours. It was a very small startup, and it was a huge learning curve because there were so many different new and constantly changing technologies I had to grapple with. And I put in a lot of long hours there. And
Okay.
I think it definitely helped me as a programmer, but it also was not good work-life balance. And now with a baby on the way, I feel like working at Stanford is definitely more of that balance that I need.
I would imagine so. Yeah, yeah. Now, what's it like working at all the startups? I mean, that's something I'm not. You know, I guess I worked at a small company, somewhat startup, but it didn't actually grow. So I don't know if I'd call it a startup, but
Well, I actually enjoy it quite a bit. I tend to prefer startups to larger companies. There's less bureaucracy, and I feel like there's a lot of opportunities to learn things.
hmm.
In fact, it kind of forces you to learn things because they don't always have, especially the smaller ones, don't have specific IT departments to set up, the various infrastructure pieces that you might need for
Hmm.
what you're working on. So you kind of, at the smaller companies, you definitely have to do everything yourself.
That's true.
So
Yeah.
it's really great experience. It's you learn a lot, and it can be, it can have downsides in the sense that, as I mentioned, sometimes it ends up being more work hours for you because you have to get it working. There's nobody else who can do it for you.
Hmm.
But on net, I would say it's worthwhile.
Sounds fun. And
Hmm.
I guess there's always that potential you'll get the unicorn and your stock options will cash in and you'll be living nice. You can retire.
There's more risk and there's more potential reward, and you kind of have to just
Yeah, weigh that.
determine for yourself what kind of risk level you're comfortable with.
Sounds good. Um, all right. Well, one more question. What advice would you give to a student today interested in pursuing a career in as a software engineer or a full stack engineer or whatever, or even going out to the Bay Area? So there's multiple different pieces of advice you could give there. But what do you think are some of the big lessons you've learned that you would like to pass on?
Well, first of all, the term full stack engineer is kind of controversial. Some people hate it and think it's kind of dumb.
Yeah.
But I've definitely worked a fair amount both on the front end and back end. So
Mhm.
it's, I would say it's applicable, but in truth, I'm probably more of a back end engineer.
Right.
That's just where I spent more time. Um, but anyway, I guess my advice would be initially, it's probably good to try and get a broad uh, understanding of web development, and
Mhm.
then you can kind of focus more on the depth. But just definitely, focus on breadth first, and then depth second. Um, be aware that you're always going to have to be learning.
Mhm.
Always try to keep your skills up to date, and you can do that in a number of ways, such as like you could read various subreddits on the internet. You could, you know, find different programming blogs that interest you,
Mhm.
um, and work on your own kind of little projects and hobbies outside of outside of work. That definitely helps keep your skills up. And
Mhm.
if there's a particular language you want to learn or a technology you want to work with, um, it's really worthwhile to just get that experience and keep your skills up. Um, I would say, especially if you're going to move to the Bay Area, one of the advantages out here is the networking, just the ability to meet people who work at a lot of interesting startups and bigger companies, and work hard to demonstrate your talents and your dedication to them so that they can recognize you're a good person to work with. And you'll find a lot of times unexpectedly you'll just apply for a job at a startup and you'll come across somebody that you worked with at a previous job.
Oh, yeah.
And so, if you have those good relationships built up, they can vouch for you and say, yeah, this is a good person, you should hire them. Definitely be proactive and try to take on more tests than those that are just assigned to you. And one of the other things would be, don't be afraid to ask questions. I tend to be pretty introverted and just I'm a little hesitant to ask questions sometimes because I don't want to ask a dumb question or that sort of thing. But I can definitely tell you, even the best engineers don't always understand stuff, and you just have to have that confidence to just ask questions if there's something you don't understand, and make sure things are like your mental model of how things work is clear before you start working. Because if it's not, later on you're going to run into problems and then have to potentially you've wasted some time and so forth. So always ask those questions up front if you're not sure.
Nice. That's some great advice. I think that brings us to our end. So thank you very much, Aaron, for your wise wisdom. I don't know what kind of wisdom
Hopefully
you
it's
have
helpful to
than wise
people.
wisdom, right?
Yeah, I would hope so.
Yeah. No, those are some. I really enjoyed it. So it was a lot of fun. Thank you very much. And this will be the end of the recording. And then.
Okay, thank you.